In this video, we shall investigate the object class of the java.lang package. We shall see that all classes inherit a common set of methods from this class. We shall start this exploration with a version of the network project that uses method overriding in its subclasses messagePost and photoPost. The object bench currently contains a sample of objects from this project. If we right-click over a messagePost object, we have access to the methods inherited from post. Notice that this inherited list includes an indication that display is redefined, i.e. overridden, in messagePost. But note that there's an additional submenu, inherited from object. It lists 9 methods. Let's try calling a few to see what happens. When we call equals, we have to supply an object as a parameter. Passing the photoPost object gives us the result false, which seems reasonable because the two objects are not the same. If we try hashcode, we get a long number. Maybe the hashcode method is related to hash maps and hash sets in some way. If we try toString, we get messagePost at followed by a number. That's probably not what we would have expected. If we look at the other objects on the object bench, we see that they both have exactly the same set of methods, and calling one or two of them on newsfeed and photoPost gives us broadly similar results. The numbers from hashcode are different. And the strings returned from toString contain the class of the particular object on which they're called, but nothing more detailed than that. The implication of what we've seen here is that all of the classes of the network project are inheriting from a class called object, even though this is not explicitly mentioned in the header of any of them. If they're inheriting from object, it follows that object must be a superclass of all of them. What can we find out about the object class? The obvious place to look for more information is the Java API. Using the list on the left-hand side, we can find it. Clicking on the link takes us to a class that's in the java.lang package, one that's available directly in every Java program. The class description tells us that class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. This explains what we've observed through the objects on the object bench of the network project. Every class has object as a superclass, even though it doesn't say so explicitly. The object class is the only class that does not have its own superclass. If we scroll down the API page for object, we can see that it actually has 2 additional methods that were not listed by BlueJ because they're not public methods: clone and finalize. Let's briefly look at what the methods we tried out are meant to do. The description of equals says, indicates whether some other object is equal to this one. That seems fairly obvious, but the nature of equality is actually quite complex. For instance, for 2 objects to be equal, do they actually have to be the same object? That is, an object cannot be equal to a different object. Or should objects of the same class, having identical state, always be considered to be equal? Might it be possible for objects of different classes to be considered equal? We shall leave those questions unanswered for now. The description of hashcode starts by saying, returns a hashcode value for the object. This method is supported for the benefit of hash tables, such as those provided by HashMap, so we were right in our earlier conjecture. Finally, the description of the toString method says, returns a string representation of the object. Well, the string representations we saw weren't terribly useful, given that the contents of the post objects we called them on were much richer than we saw. If we read a little further in the description, we can see why. The toString method for class object returns a string consisting of the name of the class of which the object is an instance, the @sign character, and the unsigned hexadecimal representation of the hash code of the object. Once again, that matches what we saw. Why doesn't the toString method return something more useful than this? If you think back to the situation we were in with version 2 of the network project, you'll recall that the display method of the post superclass was unable to print full details of the messagePost and photoPost objects because it didn't have access to details of the subclasses. With the methods of the object class, we see the same issue big time. The object class is the ultimate superclass of every class we can ever write. There's no way for its toString method to cater for all the different combinations of data items that might possibly be stored in its subclasses. As a consequence, it just returns a lowest common denominator string that contains the dynamic type of the object it's been called on and the hash code of that object. If we want anything more specific, then we have to utilize the same solution as we used with the display method in the network project, overriding. If we override the toString method in our classes, then we shall be able to create, in the words of the documentation we see here, a string representation of the object the method is called on. That's all well and good, but why should we bother? We're already able to print the details of post objects, for instance, by calling the display methods. Why should we duplicate that functionality in a toString method? The main reason for considering this is the fact that, as we now know, all classes are subclasses of object, and all objects therefore have a toString method. As a consequence, methods are often written that take advantage of polymorphism by defining a parameter type object and then calling the toString method on that parameter. One particular example is the println method that we've used repeatedly to print text to the terminal. While we often tend to think of this as being part of the system class, it's actually part of the printstream class, because system.out is a public field of the system class that has the static type printstream. Here we can see that, as well as having a version of the method that takes a string parameter, this is the one we usually call, there's a version with an object parameter. The method tells us that this method calls string.valueOf to get the printed object's string value. In the valueOf method, we see that it too takes a parameter of type object, and the value of obj.toString is returned. A consequence of this knowledge is that when we want to print the details of an object, we should shift our focus from writing methods such as display and override toString instead. If we do that, then we can take a different approach in the show method of newsfeed, for instance. Instead of writing post.display, we can now write system.out.println post.toString. Or even better, system.out.println post. Because we've not yet overridden toString, we don't get what we want, but details of how to do this can be found in the chapter. Furthermore, the chapter also covers material on overriding both the equals and hashcode methods that are inherited from object. In summary, in this video note we've seen that all classes have the object class as a superclass. We say that the object class is at the root of the inheritance hierarchy. As a consequence, all objects inherit the methods of the object class. While the implementation of those methods in object is necessarily basic, they can be overridden in subclasses. The fact that all objects have these methods can be taken advantage of in other classes. For instance, the hashmap and hashset classes use the fact that all objects have a hashcode method to manage their collections. You can read more about these aspects of Java in the chapter.